All right, hello everybody. Today we're going to be looking at section 5.2, and it's called Discrete and Continuous Domains. Before we dive into this section, I just want to take a second to do a little bit of review from 5.1 because I know that in 5.1 there's a lot of different things we talked about, and that we had the main lesson video, and then before you did your 5.1 practice extension that there was another video to watch. So I just kind of want to recap what we talked about in 5.1, and then we'll dive into 5.2. And I don't have a slide to do that, so I'm just going to cross out learning targets, and we're going to put review, and then we will get to 5.2 in just a second. So in 5.1, we talked about how we have functions, and let's say our function is y equals 2x. And then we introduced that we have inputs, right? And we call those inputs, we call those our x values, or we call those our domain, our x values. So if we have an input, and let's just say it's the number 2. Well, we take that input, we put it into our function, and then what we get, 2 times 2 would give us 4, would be our output, or our y value. That's why it's y equals, or we would also call it our range. Okay, so all these things talk about this number 4. Now if we put our input and our output together, something that you guys are familiar with is it creates an ordered pair. Maybe I should write it like this. It creates an ordered pair. Right? Now, kind of in the end and in that extension video, we talked about how if something can or cannot be a function. How do we determine if something is or is not a function? And the most important thing about that video that I talked about is that something cannot be a function if it repeats x values. So let's take our y equals 2x. And let's say, again, we want to put an input or an x value of 2 into that. Well, just like we did a minute ago, y equals 2 times the 2, and that will give us y equals 4. All right, so for the input of 2, we get an output of 4. So then we get the ordered pair 2, 4. Now, we can determine if something is a function or not based on if we have 2 inputs that are the same. We could not, for example, we could not run 2 back through this function. We could not run 2 back through there and get a different value, right? Because if we plug 2 back in, then we would get 2, 4 again. So I guess we can run it through, but if we were to put 2 into some type of function, or we have a graph that has 2 on it twice, and one time it had 2, 4, and the other time it got 2, 5, then that wouldn't make sense because we can see from our function that there's only one value that we can get, one output that we can get when we put 2 in. So when those x values repeat, then that shows us that we are not dealing with a function. All right, so that is a really quick recap of what we talked about yesterday, and that will be important to keep in mind, and those terms are things that we need to know as we dive into 5.2. So 5.2, discrete and continuous domains, and we will be looking at page 210. I always try to put the page number down here at the bottom. We'll be starting on page 210, and we'll kind of use some of the examples and things from the book. So if you want to follow along with us in the textbook, then you can go ahead and do that, but otherwise we'll keep going. Our learning target for today is to graph discrete and continuous data and determine whether functions have discrete or continuous domain. So really 2 things. We want to be able to graph discrete and continuous data, and then we want to determine whether the functions have a discrete or continuous domain. So first, let's break apart some of these terms. So the term discrete, the domain is discrete because it consists only of the numbers 0, 1, 2, 3, and 4. So the example that the book gives is it has tickets, someone that's selling tickets, and they say for every ticket, here is right here is the equation that you can use to get the price. So our domain is 0 because you could sell 0 tickets, 1, 2, 3, or 4 because they must have only up to 4 tickets or something like that. Now, the reason that this is discrete, if we look at our term closely, discrete consists only of the numbers 0, 1, 2, 3, and 4. Now, it doesn't consist, and opposite of that, it does not have 1/2, it doesn't have 2.5, it doesn't have anything in between. It is only those 5 numbers. So that's what makes it discrete, is because it's contained. It doesn't have any numbers other than the ones that we can list. All right, so we can't split a ticket in half. We have to have the whole number 0, 1, 2, 3, and 4. Now, discrete doesn't always mean that's a whole number. It could include 2.5, but it has to be something that we list or something that makes sense with what the domain is. It wouldn't make sense to have 2.5 tickets. So our domain is only whole numbers, and it is discrete. And one more thing to point out there before we move on. If we look at how this is graphed, notice that the graph is just points on the graph. These points are not connected because this value is not on there. Something in between the point is not on there. So it's just those individual points that we have on our graph. Now, if we look at the idea of being continuous, the domain is continuous because it consists of all the numbers from 0 to 4 on the number line. So if we look at our graph, that's not a very good color. If we look at our graph, these points are connected. So that means that every single little point in between is part of our domain and a part of our range. All right, and we represent that. If we look up here, I didn't talk about it all that much, but our domain, we just listed those numbers. You can see right there, 5 numbers. You can see right here, 5 numbers. With a continuous domain, it's all the numbers from 0 to 4. So that's way too many to list. It's like an infinite amount of numbers. So that means that 1.9876543 is inside of that domain. So, I mean, if you were to list all of the numbers that are in the domain and the range, it would just go on and on and on. So that's why it is continuous, because it's every single number from 0 to 4. And again, we're talking about our domain here. We're talking about our domain. So we're starting to get used to this idea of a discrete domain, which means that we can count them, we can list them, or a continuous domain, which means it just keeps going. It's all the numbers in between. To kind of define them a little bit more, when we define them up here, we just said the idea of discrete is that it is countable. The idea of continuous is that it just keeps going and going and going. It continues. Now, if we talk about a discrete domain, we're adding this word domain. That should ring a bell from yesterday. Remember, domain is the same as an input or an x value. So when we say discrete domain, then we're only talking about the x values. And that's why we have something that looks more like a number line here for the picture, because we're only talking about the x values if we're looking at a graph. So a discrete domain is a set of input values or x values that consists only of the certain numbers on the interval. So this only is 1, 2, 3, 4, and 5. Now a continuous domain, still talking about those x values or the input. A continuous domain is the set of all input values that consists of all numbers in the interval. So this is every number from 1 to 5. So we could choose any little number in between here, and it would work for that domain. It would work for one of the x values. All right, so just being a little bit more specific, of a discrete domain is the kind of countable or locked in, it's only these values, and that is our discrete domain. Continuous domain could be any number of values. Continuous, it keeps going, but it's still a set in a range, or it's still set from 1 to 5, but there's a bunch of numbers in between. So let's take a look at a couple practice problems. So the directions say, and if you can't see, now we're on page 214, doing one of the practice problems there. A couple steps. First, we have to graph the data. Then we need to describe the domain and range. And then we need to answer, is the domain discrete or continuous? Okay, so let's start with the first step. Let's graph the data. So at 0, we go 1, 2, 3. I might want to change color. 0 to 3. At 1, we go all the way up to 6. So 3, 4, 5, 6. And I might have made this graph too small. And not in a good place. So let's try again. So we had 0, 1, 2, 3. We had 1, 4, 5, 6. And then we had 2, 7, 8, 9. All right, and we're not going to connect these dots. We're not going to mess with them yet. We're just going to take a look at what our domain is first, or what our x values represent. So here's really the decision point. If we look at our table, what are we talking about? What does 0, 1, and 2 represent? Well, it says input years. So we're talking about years. Can we have half of a year, or a quarter of a year, or a third of a year, or break down a year at all? Well, yeah, we definitely can. We could say that at half a year. If they wanted to have another data point in here, they could put 1/2, and who knows where this would be. Maybe it would be at 4.5. And they could add that extra data point in there. They could split here. They could break it up in a lot of ways. So we would connect these dots, because we look at our domain, or our x value, and what it represents, and it represents years, and we know that we can split up years. So we're going to connect those points for our graph. So we graphed the data. Describe the domain and the range. So now we need to just write, what is the domain and what is the range? Well, remember the domain is our x values, so we know it starts at 0, and we know that it ends at 2, but since it is continuous, it includes all the values from 0 to 2. So we'd say 0 is less than x is less than 2. That is how we describe the domain. We say the domain can go any number including 0, from 0 all the way up to the number 2. In the range, see, it starts at 3, ends at 9. Less than 3. This time that is our y, is less than 9. So that is how we describe the domain and the range. And since it is a continuous, since we see, we answered the last question already, we see, is the domain discrete or continuous? Well, we see that it is continuous, because the domain is something that we can split up, and that it could be at half a year or 1.5 years, or we could split it up in between the numbers that they give us. So we see that it is continuous. And since it's continuous, we say the domain can go from 0 to 2, and by writing it in this form, that tells me, or tells the reader, that it's any number in between 0 and 2 for the domain, and for the range, it's any number between 3 and 9. So let's take another look at another practice problem. First, your job is to graph the data, and then describe the domain and range, and then say, is the domain discrete or is it continuous? This is where you should have a piece of paper and a pencil out, or you could even switch to like Notability or something like that on your iPad, and I would like you to do this one on your own. So go ahead, try out that problem, and then once you're done, hit play and I will take you through it. All right, welcome back. You should have tried this problem on your own, so you have something to check your work and my work against, but I'm going to walk through it. So first, we're graphing the data. We have points 0, 0, and then 1, 8.5, so we'll just go by 2s. 2, 4, 6, 8, 10, and it's just over 8. So that would be like here. And then 2, 16.9. So we're at 10, 12, 14, 16. We were just over 16, so we're going to have to bleed up there into the table a little bit. So that would be like here. Now we need to decide if these individual points are just going to stay where they're at, or if we need to connect them with a line. So we take a look at what our input is, or what our x value is, and it's hats. And this is where you should have thought, well, I can't have half a hat. It's like with years, we could have a year and a half or half a year. But hats, we're not going to split up at all. You either have 0 hats, 1 hat, or 2 hats. So we just leave those points as is. We do not want to connect those. So then when we are describing the domain and range, the domain, it can only be 0, 1, or 2. And the range could only be $0, $8.45, or $16.9. So in these two practice problems, we graphed, described, and said whether it's discrete or continuous for a problem that was continuous, right? Because years we could break up, and we're looking at what the domain is. That's why we talked about the discrete domain, because really we're focused on the domain, not so much the range. So we had one problem where we had a continuous domain, and one problem where, I guess I didn't write it here, but we have, I gotta change colors just to stay consistent. We have one problem where we have a discrete domain. Now let's take a look at our learning target to wrap up. Was to graph discrete and continuous data. Well, that's what we did in both problems. Here we graphed a continuous data set from that table, and here was a discrete. And determine whether the functions have a discrete or continuous domain. Well, that's exactly what those practice problems had us do. So I would say if you followed along and you understood the concepts that we talked about, then you nailed the learning target for today. And as you go on to do practice 5.2 or 5.2 practice A, then that should be something that goes very quick for you. As always, if you have any questions, make sure that you email me and we can set up a time to talk, or I can answer you in an email. We'll go get things figured out.